Start recording. Okay. We'll continue with chapter 2. Okay, chapter 2 we have we're talking about exponential and log, though there will be 5 sections. Okay, so previous lesson we already deal with A and B, which is indices rule and log rules. Okay, so and you are asking to do some algebra, okay, to get used to the indices rule and the log rule. So we have a 12 indices rule here, then we have a 11 log rules here. Okay, then you are asking to deal with the algebra here. Okay, so now we are going into natural E and the natural log. So section C here. Section C here, we have a natural E and natural log. Okay, so you need to know what is E. E. Okay, so E is a value. Okay, that is equal to let's see, press calculator. If E, so you have a 2.718281828. Okay, 1828. So it's a number. This number is actually coming from nature. Okay, from nature. Okay, and just like pi. Okay, pi also a number that is discovered from nature. Okay, therefore over here, okay, this is, as you can see, this is an irrational number. Okay, what does it mean by irrational number? Natural number means a number that cannot be written as a fraction, that it actually can continue forever. Okay, the decimal place. So E is a number. So how do we actually get this number then? So E here is defined as 1 plus 1 over n power by n. Sorry, I'm missing the limit. Okay, it's a limit to in n goes to infinity. The value E is defined in this way. Okay, E is limit from n to infinity, 1 plus 1 over n to infinity. How do we actually know that? Okay, so let's say we start with the n. Okay, when 1 plus 1 over n power n. So if we start with 1 here, okay, let's say 1 plus 1 over n power by n. Calculate. If I start with 1, okay, I have a value 2. If I continue with 10, okay, so you have a 2.593742246. If I continue to 100, okay, then I have 2.7048133829. If I continue with 1000, okay, I have 2.71692392. If I continue with 10,000, 2.71814597. Okay, let's go more. Okay, 60 at the back. Okay, calculate. 1, 1, 2, 3, 4, 5, 6. Okay, I have 2.718280469. So therefore, when we go to infinity, it will be 2.718281828. It stopped changing already. So therefore, it defines it in this way. Okay. So E is actually this, number 2. Okay, where can we find E? Can we find E in real world. Okay, E is actually relatively important. We can see in biology, we can see in engineering, we can see in economics, we can see it in business. Okay, we can see in geography. Okay, so actually many and etc. Okay, so therefore somehow E is actually have related to our daily life. Okay, so this is E, a value E. Okay, again, E is a number 2.718. Okay, it's actually come from the nature and it defined in this way. Number 3. Okay, then function EX. Okay, function EX. So I better write as a fx equals to AF. Okay, so EX. So the EX here, so it's a function of EX. So as you can see, just like our indices rule, the A power X form. Okay, so the EX here, it will be defined as limit of n goes to infinity of 1 plus x over n power by n. Okay, so it becomes a function. And this function EX here, okay, will follow a graph that actually look like this. Okay, EX. Okay, we pass it through 1. Okay, if we compare to with different base, okay, if it's a 2 power of x, it will be a flatter. Okay, if it's a 3 power of x, it will be steeper. Okay, therefore E is a number in between 2 and 3. Okay, but as a comparison, you can actually see which one is flatter, which one is steeper, but all of them passes through 1. And therefore from here, you can see the domain. Okay, the domain is x is everything, and the range, okay, y more than 0. And you can see there is a horizontal asymptote. Okay, horizontal asymptote for y equals to 0. Okay, this is EX. 4. Natural log. Okay, so we call it LN. Okay, LN. Okay, LN here means log base E. Log base E. Okay, LN. So from rule 0, okay, of the log rule, okay, we say if AX equals N, then log AN equals X. Similarly, okay, so if it's in the form of base E, if EX equals N, then log EN equals X. But instead of writing LOGE, we write LN equals to X. So this, therefore, as you can see here, whatever the log rule actually apply over here. Okay, whatever the log rule apply over here. Okay, number 5. Okay, so function fx equals to ln x. Okay, because they are inverse functions of each other. Okay, y equals to ex and y equals to ln x is inverse of each other. Okay, from your P1, you already learned that if it's an inverse function, okay, will be reflection under the line y equals to x. Okay, under the line y equals to x. Therefore, if the EX graph look like this, hence your LN graph will look like this under the line of y equals to x. Under the line of y equals to x. So you will see that from here, this is 1. Okay. So from the blue graph, you actually can see that from the blue graph, you actually can see that the domain for the blue, okay, is x greater than 1, and the range is y is everything. And over here, you will see that there is a vertical asymptote of x equals to 0. Okay, so that will be the function of ln x. So up to here so far, you will see that nothing new at the moment. Okay, nothing new at the moment. The only thing that being new here is the letter e, the value e. Okay, so you will see that the graph is still doing the same thing. You will see that the indices rule, the log rule is still doing the same thing. Okay, the reflection graph is still doing the same thing. The only thing that new over here is the letter e. Okay, so number 6, why e is important? Okay, why ex is important? From above, we say that e appear in the real world. Okay, oh, no doubt, this is appear in the real world. Of course, it's important. But why the e thing is so important for our calculation? Because, okay, a function ex is one of the two function in the world such that its differentiation equal to itself. Okay, if we write it mathematically, dx of ex equals to ex. Why is it important? Because function ex is one of the two functions in the world such that its differentiation equals to itself. Therefore, it's important. Okay, therefore it's important. The further math students will need to know the proof. Proof for FM student. Okay, so you'll know you need to learn how to actually prove this works. What if it is not x? Okay, what if it is not an x? So the extension, the modifications of it is, okay, the dx of e of fx will equals to f prime x e fx. If you want, you can actually memorize this rule instead of this one. Okay, so this is why the e is so important. Okay, so this is section C, natural e and natural log. Okay, for algebra purposes, let's try to look at some questions. Okay, let me try to extract some questions. Okay, allow me to demonstrate some example here. Okay, let's say, okay, I have A. Okay, A. So e2x minus 8ex plus 12 equals to 0. So this is all the algebra work. Okay, algebra questions. Okay, so over here, so ex will be write this in the form of quadratic. Okay, first of all, we will write it as a form of quadratic. Then after that, we factorize them. Minus 8 and this one is 12, so minus 6 and minus 2. Okay, we have minus 6 and minus 2. Then, okay, because of the factorization, so ex minus 6 equals to 0 and ex minus 2 equals to 0. Okay, so after that, you have ex equals to 6, x equals to ln 6. Okay, then ex equals to 2, okay, x equals to ln 2. So that will be your answer. The problem here is, will students, when they handling this kind of question, will they have enough algebra techniques to actually deal with this type of questions? Okay, so it's all based on your experience, purely based on your experience, nothing new over here. Okay, purely depends on individual skill. So B is similar. Okay, let's go for C. Okay, so if I have a ln x square plus 2 ln x minus 15 equals to 0, it's still a quadratic. Okay, still a quadratic. So if I factorize them, so I have a ln x, so plus 5 plus 2, so plus 5. Okay, ln x minus 3 equals 0. So I have a ln x equals to negative 5, ln x equals to 3. So x equals to e power of negative 5, x equals to e power of 3. That would be the answer. Okay. Okay, so over here, this will be the algebra type of question. Okay, where can you practice more of from these algebra questions? That's exactly your section 1 and 2. Okay, your section A and B. Your section A and B, all the questions that you are expected to actually solve over here. Hopefully you are already able to solve all of this, since nobody actually sent me anything. Okay, send any questions to me. So I assume that all of you are already okay with this. Okay, then for the E type, so this will be the just using E, but it's actually the same type of questions. Okay, then the next part is graph and transformation. Okay, the next part is graph and transformation. Graph and transformation. Okay, so from above, you already seen that the E graph actually look like this. Okay, you already seen that the log graph already look like this. Okay, so of course all the other transformation will be applied accordingly. Okay, but there are a few that being interesting here. Okay, let's go for the basic transformation first. For example, if let's say I have, let me just copy it down. Okay. Okay, so of course, if let's say I have ex plus 2, so I will have the asymptote goes to 2, then this value goes to 3. So I have a ex plus 2 like this. Okay, but what you need to aware is asymptote is also part of the graph. Asymptote is also part of the graph. When you transform, you also have to transform the asymptotes. Okay, this is something fundamental that you should already know. Okay, so if let's say e power of x plus 2, okay, e power of x plus 2, it will be look like this. E power of x plus 2, okay, or plus 2 as a power. Okay, then this one become e2. Okay, this one become e2, but the asymptotes remain the same because this one actually tells us this is a left-right translation. Okay, left-right translation. So if I have a 2 of ex, 2 of ex, then we will have like this. It becomes steeper now. So we have 2 here. But the asymptotes remain the same because it's a up-down stretching. Okay, because it's an up-down stretching. So if you have a e power of 2x, e power of 2x, then it will become like this. Okay, because of the compress horizontally. This one pulling. Okay, this will be e of 2x. If I have e of negative x, e of negative x will be like this. If I have a negative of ex will be like this. Negative of ex will be like this. Okay, so this is exactly like what you have learned it before. The reflection by the x-axis and the reflection by the y-axis. Okay, so okay, what interesting is all the with the modulus. So if I have a modulus of ex, it gives me exactly the same thing, no changes. Okay, if you expect modulus of ex, it will be exactly the same thing, no changes. So okay, if I have e of modulus x, e of modulus x, so I will have erase this part, copy and reflect. This part is sharp. If I'll have e power of negative modulus x, it will become like this. This part will be erased. This part is sharp. Okay. So over here, there will be something that you need to aware from your basic transformation that you have done it before. C, V. Then the next one, let's just look at the log graph. If we look at the log graph, okay, if we look at our log graph, let's see what's going to happen. What if I have a log x the whole thing plus by 2? Okay, so it will be like this, log x the whole thing plus 2. Okay, because it will be shifting up by 2 units. Okay, vertical asymptote is still the same, and this one it become e of negative 2. Okay, e of negative 2. Then what if I have ln of x plus 2? Okay, initially this is a value 1, so I will have plus 2. So I will go to here and go to here. Ln of x bracket x plus 2. Okay, this one become minus 2 now. This one become minus 1 because it's going to the right left by 2 units. So this one become ln 2. Okay. What if I have a 2 ln x? So it become like this, 2 ln x, because it's stretching. What if I have a ln of 2x? Okay, so it become like this, ln of 2x. This one become half. This one is 1. What if I have a negative of ln x? Negative of ln x will be like this, negative of ln x. Okay, what if I have a ln of negative x? It will be like this, ln of minus x. Okay, so something that students need to aware of to recall about the rules. What if I have ln of modulus of ln x? So modulus of ln x. So the graph will be like this. It becomes a weird shape. But it's a reflection, folding, not reflection, sorry, folding. Okay. What if you have a ln of modulus x? So it will be two sides, both sides. What if you have a ln of negative modulus x? Graph doesn't exist. Because we cannot log negative number. Therefore, graph doesn't exist. Okay. Then there are a few more that be interesting here. Okay. So what if I have a ln of modulus x plus 2? Ln of modulus x minus 2. Okay, and ln of modulus x plus 2. Okay, and one more. Ln of modulus x minus 2. Okay, so these type, they are harder questions. These four, they are harder questions. Okay, so let's see how to actually do this. Okay, so because of x plus 2, so first of all, the technique I'm going to teach you is I'm going to draw the graph for x plus 2 first. So x modulus of x plus 2. So modulus of x plus 2 is like this. Okay, this is modulus of x plus 2. Where do you learn this graph? You learn this graph from chapter 1. Okay, you learn this graph from chapter 1. Therefore, because of the touching the 0 here, then this part will be the asymptotes. Okay, and it will be the graph that look like this. The red part is the answer. What if I have x of minus 2? This is a 1. Okay, minus 2. So I draw the blue part, modulus of x minus 2 first. So the graph actually look like this. Okay, so this is modulus of x minus 2. Then this is the part that touching the x-intercept, therefore become asymptotes. Okay, so 1 minus 1, so this one part, it become like this, the graph. Okay, this, the red color, is your final answer. What if I have a modulus x plus 2? So same thing, I'm going to draw the modulus x plus 2 graph first. That actually give me this. Plus 2. Then only I apply the red color, ln the value. So this as 2 here. This one as 2. This one as minus 2. Okay. Then they become like this. So this one become ln 2. It's like a wing like that. So what if I have a modulus x minus 2? Okay. So it become the graph that actually look like this. Okay, at negative 2 and 2. Okay, this is the two part that actually touching the x-intercept. Therefore, you have two asymptotes. Okay, then we know that we cannot log negative number. Therefore, in between here, there is no graph. So the graph will appear here. Okay, the graph appear here. So one more, if let's say I have a ln of 2 minus modulus x. Okay, ln of 2 minus modulus x. So first I draw the blue color part. Negative 2 and 2. This become the asymptotes. And these two end side, there is no graph. Okay, because we know that we cannot log negative number. So the graph actually look like this. I didn't draw it symmetrical, but it's actually symmetrical, supposed to be symmetrical. When this is a ln of 2. This is a 1, this is a minus 1. Okay, compared to the one above, this 5 graph is a harder questions. And you need to learn the techniques. Because you don't have a graphical calculator, you don't have a software for you to do the drawing. Okay, so regardless whether you plot it point by point or actually just figure out by using thinking, you'll be expected to capable of drawing this kind of graph. These sections will be graph transformation. This section will be graph transformation. Of course, for students who are not so confident on drawing graph, okay, you just need to practice more. Okay, and you will see that the other than these 5, the rest, they are your basic transformation that you already learned it before. How to actually do the translation upwards, downwards, left, right, Okay, expanding horizontally, vertically, compressing horizontally, vertically, reflection horizontally, vertically, folding. Okay, then the one with the erase, it's all the same. Okay, they are all the same. Then after that, the last part of the topic is linear law. The last part of the topic is linear law. So what exactly is linear law? Okay, so we convert non-linear curve into straight line. Okay, so what we're actually dealing with, we're actually converting non-linear curve into straight line. Okay, this one, let me extract from the book. Okay, so logarithm and non-linear data. So over here, okay, they give us these questions. Okay, the case of y equals to ax power n. Of course, this is not a straight line graph. So if we draw this graph by itself, okay, we will get something, maybe depends on the value of n. So if it's a n square, so maybe I will get a quadratic. Okay, if it's a n equals to 2, if let's say I have a power 3, then I have n equals to 3. Of course, no matter how I draw it, it will be a curve. But if I change it into the y equals to mx plus c form, okay, in order not to confuse you, this one over here, the red color, I write the y and x as curvy y and the curvy x. Curvy y and the curvy x. Okay, then we apply the algebra. So okay, over here using log, so we can write as ln y, can ln of ax power n according to log rule, ln a plus n of plus ln of xn. So ln a plus n times of ln x. Okay, the power can actually bring to the front. So once I write it in this form, what can I observe? Okay, I realize that it fulfill a straight line form. This is like my capital Y. This is my capital X. This is like my capital M. This is like my capital C. Therefore, we managed to convert it into a straight line form. We managed to convert it into a straight line form. It's just that my graph here, okay, my graph here is not the small letter x and the small letter y, but is a ln x and ln y. And from the straight line, whatever the straight line that I draw, the y-intercept is ln a here, ln a. And the gradient will be give me the value n. Okay, so this is converting the non-straight line into straight line. Let's see for others. So let's say we have this. Okay, let's say case 2, y equals to abx. Okay, y equals to abx. So this time, earlier the x is a base, now the x is a power. Okay, now the x is a power. Okay, then same thing. This abx. Okay, so y equals to abx, ab power x. So if let's say depends on how I draw the graph. Okay, depends on the value of a and b. Okay, so if I draw it in the proper form, it maybe give us the form like this. Okay, y equals to ab power x. Okay, b power x form is exactly the exponential that we're referring. Okay, the 2 power x, e power x, 3 power x. Okay, so therefore the graph actually look like this. So of course this one look like a curve. Okay, this one look like a curve, but our purpose here is to write them as a straight line. Again, in order not to confuse you, I write this as a curvy y and a curvy x. Okay, curvy y and a curvy x. Then after that, we apply the log rules. Okay, the log rule. So maybe ln y equals to ln of ab power x. Okay. Then we have ln y equals to ln a plus ln b power x. Then I have ln a plus x ln b. Okay, so what exactly did I get here? You should aware that this one I get my y, this one is still my x. This time the ln b become my m, and this is my c. So in the end, the straight line graph that I get is not the curvy x and the curvy y, it's the x and the ln y with the this one, the y-intercept is my ln a. Okay, and my gradient is my ln b. Okay, so over here they write in the form of log, but for me I write in the form of ln because most of your exam questions will be asking in terms of ln. Okay, will be asking in terms of ln. So that's what actually happened. Therefore over here, okay, let's say let's look at some example. Okay, once you know the relationship, let's look at some example. Okay, the graph representing the growth of a population of bacteria, P over T. Okay, the graph has a gradient of 0.6 and meet the vertical axis at 0.2 as shown. Okay, so don't forget this is your capital Y, this is your capital X. Okay, so we can write it in the form of y equals to mx plus c. Then only you fill in with the information. Okay, then only after that you fill in with the information such as the y here is log p, log p, the gradient 0.6, the x is t, the c is 2. Okay, after that you are required to rearrange this algebra to get into this form. And furthermore, they ask you to write the a and b. Part A, write down the equation of the line. That means A is already done because it's referring to line. So this is a line equation. Okay, after that, I need to rearrange them. Okay, Log here, when we write log, automatically we will read as a base 10. Okay, base 10. Log will be referring to base 10. Therefore, P equals to 10 power of 0.6 T plus 2. Okay, then by using your algebra, okay, your indices rule, your log rules, whatsoever, so you have 10, 0.6 T times 10 square. Okay, then you have a 100. Okay, 10 power of 0.6. According to the questions, give to 3 significant figure. So 3.98 power T. Okay, that after doing this, what does it mean? My value of A is 100. My value of B is 3.98. Okay. Interpret the meaning of the constant A in this model. Okay, what does it mean by this constant A in this model? 100. So over here, we will say that, okay, when T goes to 0, where is my thing? When T goes to 0, okay, so you have a value of A. A equals to 100. Okay, that means for C here, okay, the value of A is when T equals to 0. Okay, the P equals to 100, which is the A value. What does it mean? It means your initial population of bacteria. Of course, for non-science students, you may be having difficulty on this type of questions, but no choice if the question actually asks in this way. Of course, not all the time the question can actually ask by using the signs in biology, because as I say earlier, okay, in the real world, it appears in anything. Yeah. Okay, it appears in anything. Therefore, this chapter, it is something practical for the real world. Okay, of course, depends on whether you have a chance to actually do the calculation or not. But regardless whether you have a chance to actually do the calculation or not, it actually happens around us. Okay, it actually happens around us. So, before I continue with the next exercises, okay, I'll give you exercises. Okay, can you tell me anything that you require to ask me, that you need to ask me? Open questions to the floor about this topic. Okay, so the main part is just the algebra and the graph. Okay, the main part is still algebra and the graph. I will write down, I will crop the questions. Let me crop the questions. Okay, so over here, okay, so this will be the combination of topics, okay, of the questions. So you have the basic, the graph question, you have the algebra questions, okay. The question two is like more like a simultaneous equation, okay. You have a solving questions, okay. You have a modeling questions, okay, modeling questions. You have a straight line questions, okay, straight line questions, and so on, okay. So next week, okay, we will go back to school, then we can actually discuss further on that, okay. So okay, do you have any more questions? If let's say you don't have any more questions, I will send the file to you, then I will upload the YouTube. You can actually do the practices. Got any questions? Okay, so that means next week I will meet you guys in school. Happy New Year. Okay, stop recording.